Thanks, Ron.
Also physics, what we take next week is coming.
The physics test, mid-semester test, is always on mechanics.
Okay.
So we're not finished mechanics yet. But I think we're nearly finished it because there's collisions, although, no, I don't know actually. I don't think, because I'm losing the two classes on Thursday. We have double physics on Thursday, right? Yeah, because I'm losing the two classes on Thursday, I don't think I'll get mechanics finished, which is a bit of a pain. Oh well.
The test is already set, isn't it?
Dude, I haven't written the test yet.
It's on Moodle.
No, that's from last year.
I think he'll upload the test.
No, but you can't access it. Like, you can only access it on Friday.
Different, because I won't have enough. It won't be the same test. I'll have to come up with something. But that's, I don't. Now I have to wait until Friday, so there's no problem. I can take as long as I want.
But I go to the
Talk in the morning. UCC was on Wednesday or something, isn't it?
Really?
Right, efficiency. 6 questions. Okay. Oh yeah, we were doing this in class, so I think they were okay, right?
No.
No.
Oh yes, yeah.
What?
I remember. I thought I did it.
Are you talking? I don't understand.
Just do it and say it.
Ignore you.
Yeah.
Okay, continuing. Right, so question 1. And here's my cat to start with.
There's no cat.
Banana
Huh? No, we start off physics tutorials now with a cat.
Ah.
Don't we?
Okay.
Oh,
Yeah. Okay. Now we can start.
Why you did?
I killed him.
Yeah.
Don't worry, you'll be okay. 3 kilowatt heater is running for 1 hour. How much work is done? Okay, so you know that power is work over time. So work is power multiplied time. So that's 3,000 multiplied by 3,600. You should do these things in seconds. So 1 hour is 3,600 seconds. I haven't opened my calculator yet. Can you tell me what that is, please?
108.
10.8 megajoules.
Yeah?
Yeah.
A forklift lifts 200 kilograms of potatoes.
Mega is 6.
Yeah. A height of 1 meter in 4 seconds. What is the power? Okay. Power is work over time. What work is being done?
MGH.
Potential energy. MGH over T. Now, we know the M.
200 G.
We know the G. We know the H. And we know the T. So this would be whatever 50 times 9.81 is.
490.81.
490.3 watts.
5.
490 watts. Then it's 491. Okay. 3. A TV is 30% efficient. How much light and sound is produced in 1 hour? Okay, so power out over power in times 100 should equal 30. Yeah. Power out over 50 times 100 equals 30.
15.
Power out equals 15. And what did I want? The energy though.
Oh, yeah, but.
Okay.
The weight.
The wastage, yeah. So power, work is power multiplied by time. This would be 15 times, the time is 1 hour. Now this is the power you get out. This is the useful power. That's not really what I want. I tried to trick you a little bit here. I didn't want the power the TV outputted. I wanted the wasted energy. So think about this. If 50 watts go into the TV and 15 watts is output because it's 30% efficient, then how much is wasted? 35 watts is the wasted power. So the wasted energy,
35 times 3.
yeah, what's that?
126 kg.
126 kilojoules.
I thought it asked the hour.
Was it the power or was it the... no, it's the energy. In 1 hour.
Yeah.
Energy.
Yeah.
Sorry. What?
Yes. Okay. 4. Brakes on a car are 0% efficient. They produce no useful output. A hybrid's engine could capture some of the lost energy. If a hybrid's brakes are only 10% efficient, then calculate how much energy is stored in the battery when a 1500 kilogram car brakes, and I spelled brakes wrong there, they didn't brake, brakes to rest from 120 kilometers per hour. So, what is the speed here in meters per second?
33.2.
This one. And the mass is 1500. So the kinetic energy, a half mv squared, a half times 1500 times 33.33 squared. What do you get here?
831.7
So again, 800.
31.7 kilojoules.
Now, if you really think about this, what you're saying is, when you're driving on the motorway at 120 kilometers per hour, you have kinetic energy of 831.7 kilojoules. When the car stops, where does this energy go?
To the engine,
This energy.
to the hybrid engine, yeah.
No, this one. Forget about the hybrid for the moment.
To the wheel.
Heat, yeah, but where in the car?
Brake pads.
The brake pads take all of this as heat energy. What the hybrid engine can do is it can take 10% of this and store it in a battery to be used later. So the energy stored would be just 1/10 of this.
83.1 kilojoules.
Yes, I too can move a decimal place. Thank you. 83.17 kilojoules. Okay.
That's really smart of the people who did this.
It is. No, because a lot of energy is wasted when a car brakes. A lot of energy is wasted. Yes, Fawn, you got a question?
Can I write this?
So,
And what's your answer at the end? The same?
Same, but it's not like.
Oh yeah, no, that's fine. Yeah, 10% is an easy number, so I just did it in my head. 10% is easy. You just move the point. Yeah, you can do it that way. Yeah. No problem. Yeah.
83.17 is for
The energy stored in the battery
what?
for to be used later.
How much energy is stored in the battery?
So this is the energy used after the car runs out of fuel.
The hybrid car usually uses the stored up energy to assist in accelerating up hills or from rest, not as an alternative when it runs out of fuel. So this will be used later when the car needs to accelerate, perhaps up a hill. Yeah. I have a hybrid. I have a Honda Civic hybrid. And it's a bit different. There's two types of hybrids. There's the like Toyota Prius, where the electric motor can run by itself. And then there's the hybrid assist, where the electric motor can only run when the petrol motor is running. So it depends on the type of driving you're doing. Prius is good.
Eco-friendly.
Yeah, Prius is really good if you live in the city, but I don't live in the city. I don't drive to the city. So the hybrid Honda Civic is nice because when I need to accelerate, I can see the electric engine assisting the petrol engine, and I get more of an acceleration. And then when I brake, I can see that the battery gets charged up. You know, but the electric engine cannot power the car by itself. It acts as like an assist to the petrol. But it's good fuel efficiency. You know, it's like 50 miles per gallon.
Why don't you use it to go?
It takes too long to drive.
It takes longer than a scooter.
I don't scoot all the way. I take the bus for most of it.
Oh.
5. Okay. A student consumes 7.2 megajoules worth of chemical energy. When they are in the gym, they convert half of this into kinetic potential and heat over 1 hour. How powerful are they? Right.
Weak.
Huh? What am I looking at? Energy, yeah. So, what was the energy?
What is
Megawatt?
Meganet.
G.
No, you were right the first time. Say it again.
Megajoule.
Megajoules, yeah. Megajoules is 10 to the 6. But you know this. You do. Right. Half of it is converted. So they're only 50% efficient. Now, what you have to really think about is the 7.2 input or output?
Input.
Yeah. So this is what we want. Sorry, not P, W. Right, so output will be a half.
3.6 megajoules. It's just
Yeah, it's just half of it. Oh, that's why I picked these numbers. 3.6 times 10 to the 6. The power is work over time, and how long are they in the gym for?
an hour.
An hour. That's 3,600 seconds. So we don't need a calculator because that's just 3.6 times 10 to the 3. So that's 1,000 or 1 kilowatt.
Can I do like we calculate the power, not half of it, just the power, and then we make half of it, like 2,000 into 1,000.
Okay, but I would prefer this way. No? Okay.
This is easier.
Okay. I can't argue with you. You gave me chocolate earlier. So if you want to do it this way, that's fine. Did anybody get number 6? Impossible? Let's have a look at it. Can I scroll down now? Yep. Okay. 6. A 9 kilowatt engine. It's 25% efficient. The engine causes the vehicle to move up a hill at a constant speed of 10 meters per second. Why is the vehicle moving at a constant speed and not accelerating? What might be the reason?
It's not accelerating.
Thank you for stating the obvious, Mr. Obvious, but I would like a reason. That's what I was waiting to hear. So the forces are balanced. So the net force is 0. In other words, the force going up the hill will equal the force going down the hill. There's like 2 forces here. One from the engine and one from gravity and friction and other things too. Resistance, everything, yeah. What do we call this type? That's right. Drag. And this one? Huh? Thrust, yes. Okay. Now, B. What is the thrust? Well, I tell you what the power of the engine is. It's 9 kilowatts. But not all of the engine is using its power to move the car. Some of it is wasted as heat and energy and so on. 25% efficient. So that means the output would just be a quarter of this. So what is that, please? That's 9 over 4. That, oh my goodness, 2.25 kilowatts. That's how much power is being used to move the engine, to move the car from the engine. But we don't want this, we want to know the force. So any ideas on how we can change the power into a force?
We know the time, don't we? No, we don't.
You answer. We know the V.
The speed, the acceleration.
We don't know, it's not accelerating
So zero.
from 0, I suppose, yeah. And we know, yeah.
The speed.
We don't have time. So
We don't have A.
What's the formula for inputs?
Delta P, MV minus MU. Yeah. Okay, let me show you.
We don't have time.
We don't have time. So let me show you. Power is defined as, now we know power, so we should start with power because power is what we know. What does power equal? Work over time. Do we know time? No. Do we know work?
No.
No. So what's the formula for work?
Oh yeah.
Do we know force?
No.
Distance?
Well, we know
Time?
speed.
Yeah, what's distance over time?
10.
Mm.
Okay. No.
Wonderful.
So force is power over 10 in this case. No, this is one you have to think about.
It's in the formula book. Like I told this today. Like
P equals FE. It is.
yes.
Are you sure? I don't think it is.
Yes, it was in the formula book. Like
Alright.
after FB, can anything equal to FB other than P?
I guess not. Okay, I'll believe you. Can I scroll back?
So what is the P?
Huh?
We use which P?
Which P? The 9 or the 2.25? So that means that's 0.225 kilowatts, which is 225, no, not kilowatts, what am I saying? Kilonewtons. So that's 225 newtons.
Why is it 0.225?
I divide this by 10 using my result here.
This is
This is what?
like if this car hits you, you want to get started off.
Would you like to test it?
225 newtons is not much.
Would you like to test it?
What is mine?
I don't know, a car moving at 10 meters per second.
The force 225 newtons. It's going uphill.
Yeah.
I'm pretty sure I can push more than 225 newtons.
That's as fast.
But
as
you're forgetting
one.
what I taught you. I said it's not the force that hurts you,
It's the impact.
the impulse, the change in momentum. Yes.
So this car is moving as fast as Wong was running.
Yes.
Yeah, I'm pretty sure.
And slower than Sam.
But I don't think she can do 10 meters per second uphill. It is uphill. Right. Part C now. Oh, my screen locked. How much wasted heat was produced in 10 seconds? So, only this much is useful, and this is the engine, so the rest must have been wasted. Yeah, so the power that's wasted is 6.75 kilowatts. Power is work over time, so work is power multiplied time. So we multiply this by 10 because I said it's 10 seconds. So it's 67.5 kilojoules is wasted in 10 seconds. Okay, let's have a look at the collisions now, I think. Oh, and there was one to do from last time, wasn't there?